and welcome to this talk, Event-Driven Architecture for the Win. The goal of this talk is to take you with us on a journey that we've made with one of our customers to modernize their architecture using event-driven architectures and Agile cloud services. But before we start, let me introduce myself a little bit. So I'm Mirna Alaisami. I work as a technology consultant at Novatech Consulting Company. And my focus lies in the area of cloud platforms and infrastructure automation. So in my daily job at Novatech, I try to help and support customers building their cloud architectures, migrating their workloads to the various cloud platforms, helping them to choose the most suitable solutions for their needs, also training and enabling them with topics like Kubernetes, containers, Cloud Foundry, cloud native methodology, and so on. And very briefly about my employer, Novatech is a consulting company with around 250 to 300 employees. We have 8 locations, 7 locations in Germany and 1 location in Spain, Granada. And our main work lies around modern software development, agile methodology, technology consulting with topics like cloud topics, application performance management, and much more. And now let's start. But before starting with the journey itself, let's see what's the story behind that journey. What led to all of that? Well, our customer was a very important customer. We were dealing with one of the leading machine manufacturers worldwide. They create and sell high-quality machines around the world. However, they recognized at some point that they are facing a lot of problems with some use cases. And it seemed, unfortunately, that their IT architecture is kind of outdated and needs some modernizing. And now, if we have a look on one of those use cases that was causing those problems, they needed to maintain a huge amount of unstructured data in various systems. So they were using various databases, file sharing systems, SAP, CRM systems, and so on. And they had their technicians which were able to fill out, edit those data using some interfaces through a VPN connection, which seemed to be a time-consuming task and causing a lot of problems. So in more details, they had their application, their interface. The technician can use that application. The application opens a Windows shared folder through a VPN connection using SMB protocol, file sharing protocol, in order to upload and store their data on their local data centers. And having a look on that picture here, you can imagine the kind of problems that may occur when the network or the connection is not very stable. And here we came into the scene, and we suggested a solution. Well, we said, let's move to cloud using event-driven architecture. And you might ask yourself, well, that sounds great, but why? And in order to answer that, as we said, our customer recognized that they were facing some problems. They need to modernize their architecture. And they were already searching for a solution. And while they were searching for that solution, they came across the term Agile integration. And they thought, well, that seems to be pretty cool and seems to be a fit in our case. However, we still need some support there. And that's, by the way, how they came to us and asked for help. And if you want to summarize Agile integration in few words, we can say that Agile integration is the approach of moving away from the traditional centralized integration models using ESPs and so on to more decentralized integration models using microservices, container-based, cloud-native architectures, allowing the communication between those microservices via APIs and events, and aligning all those integration elements with agility and DevOps methods. So here we're talking about three main pillars. The distributed ownership among the different teams working on the microservices independently. We're talking about the cloud-native infrastructure and the fine-grained delivery-focused architecture using some specialized and right-sized containers. Which benefits does Agile integration bring with? It absolutely improves agility since we are talking about, as we said, different teams working on the different microservices independently, so without deferring the whole integration work to a centralized integration team that may be a bottleneck in the whole picture. Also, those microservices can be developed, built, deployed, and changed independently, having their own production line, which, of course, improves and speeds up the production process. It also improves scalability, since those microservices can be scaled independently using the elastic scalability features of the cloud-native infrastructures. And it absolutely improves resilience, since those microservices can be deployed, isolated, they can fail over and recover without affecting each other or affecting their shared resources with other microservices. So, well, now we can see how or why we suggested that solution. Let's move to cloud. Let's push them toward more cloud-native architecture. Let's use events to communicate between those different microservices. And now it's the time to choose the right tools. So as you will see in the next steps, in each step we had different options. Each of them were great options. However, they have their pros and cons, and it was very important to know like which solution or which tool to use in our case. So starting with the cloud provider, do we want to use Azure? Do we want to use AWS? Maybe Google Cloud Platform or something else? And since our customer already had an Azure Enterprise agreement, and they had also Windows native systems, and we all know that Azure is a good destination for Windows native servers, and they provide native support for Windows servers workloads. So we decided to use Azure. It was a good fit here. Then moving to the event-driven platform. What do we use here? Do we use Apache Kafka? Do we use Confluent Cloud? Do we use Azure Event Hub? Or maybe some other platforms that support event-driven architectures? And having a look on the first three options that came to our mind, Apache Kafka is a great option that offers a lot of features. However, we needed to install and operate that in our case. Then moving to Confluent Cloud, it enables us to use the great features of Apache Kafka as a fully managed service. However, we still needed an enterprise agreement. And having a look on Azure Event Hub is a fully managed service. It offers a lot of features similar to Apache Kafka with some small differences. And the customer already had an existing enterprise agreement with Azure. So Azure Event Hub was the fastest solution to implement in our case, and we decided to try it. As we said, we wanted to start with fewer infrastructure components. We decided to use a fully managed service. However, we still wanted to avoid vendor lock-in when it comes to event handling. And since Azure Event Hub provides an endpoint which is compatible with Kafka clients, we decided to use Azure Event Hub along with Kafka clients or applications. We also needed a data storage. We had a huge amount of unstructured data, and we needed a place to store them, to manage them. We needed to upload and download them fast. And we had the options either to use Azure Blob Storage accounts or Amazon Simple Storage Services or Google Cloud Storage or maybe other storage services. And well, since we already decided to use Azure Event Hub, and Azure already offers a good solution, the storage accounts in Azure to store and manage data, and we can have a very good and fast experience with uploading and downloading a huge amount of data there. We decided also to use Azure Blob Storage to manage our data. Now, after we talked about the different tools and why we chose them, it's the time to implement the solution. So having a look on the business logic that the customer had, which maybe pushed us towards choosing some tools or implementing the solution in a specific way. As we said, they had different machines, and each machine can belong to many different geolocations. And they also had local on-premise data centers in those different geolocations and a central location where all the data should be downloaded about all the machines. So whenever the technician comes and uploads some data, it should be stored in Azure Blob Storage. And then it should always be downloaded in the central location and also in all the other locations that that machine belongs to. And only after making sure that all the data about a specific machine has been downloaded in all the geolocations that the machine belongs to, those data can be deleted from Azure Blob Storage. Now, having a look on Azure Event Hub, in Azure Event Hub, we have the Event Hub namespace, which is the management container for the different event hubs where our event or event streams can be stored. So coming from the Kafka world, the Event Hub namespace is the Kafka cluster, and those event hubs are the topics. And going inside one of those event hubs, we can see that the events will be distributed among different partitions there. So those partitions will carry our event streams. And usually, the events in a partition are stored exactly in the same order they are produced with, however, not among the different partitions. And that's why Azure Event Hub provides the feature of partitioning keys in order to be able to organize those orders somehow. So when we send our event with a key to Azure Event Hub, it will use a static hashing function in order to decide how to assign those events to the different partitions, making sure that all the events having the same key will end up on the same partition. And in our case, we also decided to use those keys in order to group our events and aggregate them according to some attributes. So we have our producers on one side that send the events with some keys. Then those events will be assigned to Azure Event Hub among the different partitions based on those keys. Then we have on the other side our consumers that are listening to those event hubs and which will receive and process their events. And we have the possibility to group those related consumers in the so-called consumer group, which will have its own view of the event hub. So it can process and receive the events at its own pace. So we can, for example, have different consumer groups for our different applications, making sure that they can process the events at their own pace. And the events on one event hub will be distributed among the different consumers in one consumer group. The consumer group will make sure that it receives all the events from all the partitions. However, each consumer in that consumer group will get only the events from a subset of those partitions. Azure also provides a cool feature, which is the Azure Schema Registry. It's a central repository where we can manage and store our different schemas that our producers and consumers can use in order to serialize and deserialize the event data. So they don't have to share those schemas. We can just manage them in Azure Schema Registry, and then our producer and consumers can use that in order to serialize the data. In our case, we used Apache Avro as a serialization type, which reduces the bare message overhead, so we don't have to send some metadata like the field names or types. Having a look on Azure Blob Storage, in Azure Blob Storage, we have our storage account, which is a unique namespace where we can store our containers. Those containers will then have those data blobs inside them, being videos, images, files, whatever. And structuring your data in those containers and blobs is a totally different thema that can be discussed in another talk because it depends heavily on your use case and needs, how to structure that. Now, at a glance, if we look at the solution, we defined an event hub namespace for our customer. Inside that event hub namespace, we created 2 event hubs or topics, one for the data uploaded topic events and one for the data downloaded events. We also created a storage account for our customer where we can store our containers and data. On the other side, we had our microservices or applications, the cleaner service, the downloader services, and the uploader services. And whenever a technician comes and uses the uploader service, the data, along with some metadata about the machine itself, will be uploaded to Azure Blob Storage. Then an event will be published to the data uploaded topic or event hub. And we have also our downloaders, which are listening, which subscribe to that data uploaded topic. They will receive the events, and they will decide whether to download the data based on the location of the machine itself. And as we said, the central location will always download those data. And the cleaner is also listening to the data downloaded topic, to which those downloader will send also downloaded events after downloading the data. And the cleaner will make sure to only delete the data after receiving all the events from all the locations that the machine belongs to. However, having a look on that at a glance, maybe you can see that there's still something missing, isn't it? Can you maybe guess what I have in mind? Because I'm sure you have pretty cool, creative ideas, but let's see. Do you miss anything here? Okay, then let me answer that. Well, of course we are missing something. What about security? We need some security components and aspects here. So we needed to encrypt the data and store them encrypted in Azure Blob Storage, and then decrypt the data while downloading them and store them decrypted on our local data centers. And that's why we made use of Azure Key Vault, where we could create our encryption key, and then our uploader and downloader could make use of it and encrypt and decrypt the data. We also made use of Azure Active Directory, which is a cloud-based identity and access management service that enables us to manage our authentication and authorization processes. And first of all, we needed to register our application, and this is a very important step in Azure Active Directory. And app registration is the process of adding an identity for your non-human applications to Azure Active Directory. And after registering our applications, we create 2 objects: the application, which is a unique application object that resides in the tenant where we registered our application, and the service principal object, which manages all the access policy and permissions among the different subscriptions. Then, in order to authenticate our backend applications against Azure Active Directory, we created some client secrets for our applications. And then, using the client ID and client secret, we could authenticate our backend applications against Azure Active Directory. And since those client secrets have some expiry dates, we needed to have a cron job that manages all of that and make sure to update those client secrets and store them in encrypted in some database where the customer store some important credential data for their use cases. And then the applications could make use of that and authenticate against Azure Active Directory. For the front-end part, we still needed to authenticate our users against Azure Active Directory, and that's where we used the OpenIT Connect middleware to sign in our users to Azure Active Directory. Then we needed to authorize them to use the application because we didn't want that all the users will be able to upload the data, only some users which are authorized to do so, and that's why we define some application roles after registering our application and then assign those app roles to our users. Now, after authenticating our application and our users against Azure Active Directory and then authorizing our users to use the application, it was the time to authorize our application to use other Azure resources. And here we had different options to do so. So for example, for Azure Event Hub, it was either the OAuth2 or the shared access signature. In the case of Azure Blob Storage, it was either Azure AD with the role-based access control or a storage account access key. In the case of Azure Key Vault, it was either Azure AD or Key Vault access policy. And since we decided to standardize that somehow and give our applications fine-grained permissions to be able to use the different Azure resources, we decided to stay with the Azure AD and OAuth2 option. With that, let's start with the demo. So as we said, our technician can come and upload some data. And let's imagine using the old architecture. Our technician is on a business trip, maybe attending ContainerDays, and they needed to upload some data in their hotel room where the connection was not very stable. Most likely, they would end up seeing something like this using the old architecture. And now, let's try to simulate that using the new architecture that we suggested to use. And in order to do that, first of all, I'm just going to start the front-end part here, and then I will make use of the cool feature in Google Chrome to be able to simulate some network throttling there. And I will say, let's use the slow 3G connection here and make sure that it's being used. And then I will try to upload some data about some machine using that slow 3G connection to see what happens there. So I'm going to assume that it's in Stuttgart. I will use some sample data here, and I'll press the upload button. Let's see what happens. Well, the data uploaded successfully, and we can already see a huge difference. And if we just, I'm going to stop that here so that we don't take too long, and then go to our Azure Blob Storage and go to our containers and refresh that here, we can see that our data are already uploaded to our container. And we can have a look on that and see that our data are encrypted here, and they are uploaded with some metadata, which are base 64 encoded, except for the encryption data that Azure expects to see unencoded or unencrypted in order to be able to read the Azure Key Vault key value from there. Now let's go back here and try to upload something else. So I will upload something that belongs to Hamburg here. I'll choose the file belonging to Hamburg, and I will just upload the data. And it says uploaded successfully. So I'm just going to make sure here, quick. Yeah, it's uploaded. Now let's go to our backend part here. I hope you all can see that. So I'm going to start the instances here. And what I will do is that I will start 3 consumer groups, one in Stuttgart, one in Hamburg, and one in Frankfurt, assuming that Stuttgart is the central location that should download everything. And in Stuttgart consumer group, I'm going to start 2 instances, 2 consumers. So the events should be distributed among those 2 consumers. In Hamburg and Frankfurt, I'm going to use only 1 consumer that should receive everything. And let's just start them and see what happens. So the first consumer here received a message that some data has been uploaded in Hamburg, and it says, I'm the central location, so I have to download all the data. And if we go here to Stuttgart folder, we can see that it downloaded the data belonging to Hamburg. Exactly the same happens with the other consumer in the same consumer group. It received the other event belonging to Stuttgart, and it also downloaded the data belonging to Stuttgart, since it's the central location. The other 2 consumers belonging to the other consumer groups received all the events, and in Hamburg, it decided to download the data belonging to Hamburg, since it is in Hamburg, so that belongs to me, and it downloaded the data here. And then it ignored the data belonging to Stuttgart, since it doesn't belong to me, and I'm not the central location, so I will ignore that. And in Frankfurt, it should ignore both of them, since they don't belong to Frankfurt. All right, so with that, I will say thank you so much for your listening, and do you have any questions?
Cool, thank you, Mirna. Yeah, interesting how you all went quiet when you were asked about security. Somebody else's problem, eh? Cool, all right. I don't know if there are any questions. If there are any questions, scan the QR code or raise a hand. We can do it old school. It's nice if you do use the Slido, because then the people online can also see the questions. Are there any questions on Slido? We'll check.
And by the way, if you have any questions, you can also have some conversations with me at our Novatec booth outside.
Cool. All right. So no questions. I think they're all itching to go for lunch. Before you go, yes. I will keep you here for a bit. Again, thank you very much. There you go. Somebody just asked a question. Do you think Azure Auth is safe for future development?
Oh. It's pretty tricky to answer that question, I would say, like my opinion in that. To be honest, I can't give a strict answer here, like to say, yeah, it's for sure safe or it's not safe. It always depends on the use case and your needs and the level of security that you need with your applications and your cases.
Cool. All right. And then we've got also, how do you manage encryption in transit?
Where is that?
The first one. So they can vote for them.
Okay. Sorry. How do you manage encryption in transit? You're talking about encrypting the event data themselves. If this is the case, if I understood that correctly, it's being managed by the TLS protocol, with the using the Kafka clients to send the events.
Okay, maybe one last question. I'll go for the technical one first. Why not use system-managed identities instead of service principals?
Yeah, because in the case of our customer, it was very difficult to move their applications to the cloud that fast. They had many different on-premise applications that needed a lot of work to make them cloud native somehow and move them to the cloud. So for the time being, we decided to stay with our solution. And maybe as a next step in the future, we can produce that or introduce that as a solution.
Cool. Is Johnny Five still alive? Is he still alive? Probably. Okay, well, I'll let you all go to lunch. During your lunch break, do visit room K4, where you can get some candy, cool T-shirts, visit the sponsors. Again, visit the sponsors. We wouldn't be able to do Container Days. Thank you, Mirna.
Thank you so much.